This lecture accompanies the first part of chapter 6 for CIS 307 as part of the Iowa Community College Online Consortium. Chapter 6 is Database Design 2, Design Method. It starts off and talks about the information level design and the physical level design, and understanding the differences between these two steps through the design process. The majority of the chapter is spent on the information level design. The information level design is done independently of what database management system you're using. In other words, what you do in those steps is the same whether you're using Access, Oracle, or any other database program. The physical level design is much more dependent on the database management system that you're using. So with the information level design, well, either way, really, you need to understand what user views are. User views are taking instead of trying to bite off the entire thing at once, you go and figure out one specific user or group of users, what they need, and you break this overall design down into smaller tasks by each individual piece or process. And then after you have designed each small task, then you're going to take those smaller tasks and you're going to merge them in together into one cumulative design. This is especially important to do with large database designs. It also helps you tackle each piece in these smaller groups. Now, generally, you're going to do some of this through your information level design, and you're going to come back when you get to your physical level design and you start to design the user interface, and you're going to keep going back and back again and again to these same user groups in these smaller tasks that you've broken out. Information level design method, they begin to discuss it on page 184. And what we're doing here is for each user view, so like each smaller task, I want to represent that user person or group, but that view as a collection of tables. Then I need to normalize these tables. Then I need to identify the keys in these tables. And then I merge the results of that into my overall cumulative design. So let's suppose just for a moment that we had a task of keeping track of employees and departments. And in this theory, one department could have many employees, but one employee could only work in one specific department. So when we looked at the table design, we would need a table for department. The department number would be the primary key. Notice it's underlined, it's representing primary key. We would also have to keep track of the department name and the location. And the employee would need a table. Again, employee number is underlined, so that's my primary key. And I'm going to keep track of the employee's last name, first name, street address, city, state, zip, their wage rate, their social security number, and their department number. Now, as a side note, the book uses this example properly, but just in case you do leave and try to design something, I'm not thrilled with wage rate being in the employee table. I feel that you would most databases would want a history of the wage rate, and so that would actually be off in another table. In this example, you would not be able to keep a history. It would only be whatever the most current wage rate is. So the first step was to determine the entities involved and to create a separate table for each entity. So if your task was to keep track of which employees worked in which department, the first step would be to determine and to name those tables. So we would determine that we need to have a table named department and that we need to have a table named employee. Step 2 of this information design process, it'd be to determine the primary key for each table. So we can usually determine the primary key easily. Other columns take longer to figure out, but Usually at the same time that you can determine there's a need for a table called department, we probably at that point know that the primary key of that table is going to be department number. And when we've determined a need for employee, we've probably identified the primary key as employee number. Then, in order to continue identifying that collection of tables, we need to determine the properties for each entity, or in other words, the remaining columns in each table. So I've already determined that I need a table department with the primary key of department number, but now I'm determining that I also want to store the department name and the location, and that in that employee table I also want to store the last name, the first name, the street address, etc. for each employee. The fourth step would be to determine the relationships between the entities. So in other words, I need to determine the foreign keys. So in my department table, there is no foreign key, so I'm just going to close that off with the closing parenthesis. But in my employee table, there's a foreign key of department number. So I need to include that field in the employee table in order to handle the relationship between department and employee. Now, in that first example, I made an assumption at the beginning that one employee could only work in one department. What if one employee did have the ability to work in more than one department? For example, maybe I had a file clerk who worked in the accounting department in the morning and worked in the sales department in the afternoon. In that type of a situation, then I need to have another table. So I still have my department table. I still have my employee table. Notice there's no department number in my employee table. And I now have a third table called Works In that lets me know which employee works in which department. So here I could have an employee number 5 be in department 6 and employee number 5 be in department 7. So when I determined that collection of tables, which was really the first step, and it has the 4 sub-steps, but as I determine that collection of tables, I really have to graph it out. So a lot of this stuff kind of happens simultaneously. Remember, there are different types of keys, and they begin to talk about some of the keys. Again, this is mostly review, but on pages 186 and 187 they talk about this. Remember, we have something called an alternate key, a column or collection of columns that could have been chosen as the primary key but wasn't chosen. A good example of this in the what we just looked at would be the Social Security number. Social Security number is a unique identifier. We could have used it as the primary key in the employee table, but we chose to use the employee number instead. So Social Security number would be an alternate key in the employee table. Remember secondary keys. Secondary keys are a column or collection of columns, usually a column, that are of interest strictly for the purpose of retrieval. We're usually going to create a non-unique index for each secondary key. A good example of this would be something like the employee's last name. It's very common that we're going to search and query off of that last name rather than the employee's ID number, so we may go ahead and create a non-unique index for that secondary key in order to speed up that search and retrieval process. Foreign keys, remember, are a column or a collection of columns in one table where it is not the primary key of that table, but it does match the primary key of another table. Remember, this is referred to as referential integrity. So that step of identifying all the keys means that not only when I look at this table, I'm going to identify the alternate key of the Social Security number. I'm going to identify a secondary key of last name, and I'm going to identify a foreign key of department number functionally dependent on the table department. If we were to look at this in database design language, commonly abbreviated as DBDL, we would now reference this in this manner. So similar to how we started, we have the name of the table, all the fields in parentheses separated by commas, the field that is the primary key or fields that are the primary key underlined, Underneath, indented, I've got AK for alternate key, social security number, SK, secondary key would be last name, FK, foreign key, department number, functionally dependent on table department. If we were to diagram this, which they begin to do on page 188, with the ER diagram abbreviations that they use or style that they use within the chapter, it would look similar to this. Now, I did a number of ER diagrams for the lecture here today, and I used Google Docs for all of these drawings. I simply went to Google Docs and chose to create a drawing and was able to do all of the shapes that you'll see here within this presentation today. So when we get to the point where you are needing to visually represent some of these table designs, I would highly recommend that you just use Google Docs because it is going to have all the options that you need. So here's my table department. Notice that any fields that are part of the primary key are designated in the rectangle above the line. Any additional fields are designated below the line. Here's my table employee. There's my primary key field above the line, my other fields below the line. Notice the SK for secondary key in parentheses, AK for alternate key in parentheses, FK for foreign key in parentheses. Notice the line between the two tables. I just went from the center of one table to the center of the other table. Notice that the line is represented by dashes. The dashed line here indicates the relationship. Notice the dot at one end of it, that indicates the many. So one department has many employees. So I can look at this graphical representation and figure out a lot of different information just by the various shapes and lines that are drawn. And then I need to, in the final step, I need to merge it into my cumulative design. So let's suppose for purposes of this example that my prior design of the employee table had this. So based on other user views, I already had decided I was going to have the employee number, last name, first name, wage rate, social security number, and department number. With the user view I just completed, I know that I need the employee's number, last name, first name, street address, city, state, and zip. So notice that with this view, I did not think that I would need the wage rate, social security number, and department number. But with my prior views, I did not yet have the street address, city, state, and zip. So now I'm going to merge them together into one view. It's the same primary key, so it's very simple to merge them together. I'm simply going to have any fields that are repeated, like the employee number, last name, first name. I only want to list once, but ultimately I want to include all the fields from both tables, never listing a field multiple times. So when I've merged them together, you can see this is now my table from both views. There's a flow chart of an information level design on page 190, figure 6.3 in your text. Again, remember the 4 steps. Number 1, represent the user view as a collection of tables. Normalize these tables. Then represent all the keys. And then merge the result of the previous steps into the cumulative design. So there are 2 chapter examples that we're going to go over, and the first one, example 1, begins on page 190. It's in the blue box, and there's actually 4 separate user views that are analyzed. So imagine that we meet with a user or group of users, and they basically tell us that for every sales rep, they need to know the sales rep's number, name, address, their total commission, and their commission rate. Again, I do want to emphasize that while the author does include some of this payroll information in the rep table, you would probably want a history and you would not include it there. But for purposes of this example, it's going to work fine. So I meet with a group of users and this is what they want to know. So I leave and I sit down and I go, okay, how do I need to design that? I figure out that only one table is required. And I determine that that table is going to be a table rep. I determine that the primary key is rep number, and I figure out what other fields are necessary. So there's my collection of tables that are needed to meet this user requirement. Then I would make sure the tables are normalized. Again, make sure that all keys are identified. There may be an alternate key or a secondary key that I need to identify. I don't have any in this case. And then I would merge it into the overall design. Of course, since it's user view 1, there I don't have anything to merge it into. So then I go and I meet with another group of users, and they say, well, for each customer, we need to know the customer's number and their name, and we need to know the sales rep who represents that customer. And I ask questions, and we figure out that a sales rep can represent many customers, but a customer can only have one sales rep. So the first thing that I need to do is figure out my collection of tables. I break that down by determining the tables. I figure out 2 tables are required, one table for rep and one table for customer. I figure out that the primary key of these tables are rep number and customer number. And I identify the other fields that are required to be in each table. So at that point, I've pretty much figured out what my collection of tables is. Then I'd look to make sure that the tables are normalized, which they are. And then I would identify any keys. So I need to have the rep number included in table customer as a foreign key in order to come back and be a rep number. So I do have a foreign key. And if I did have any type of a secondary key, I would identify it also. Maybe a secondary key that they'll commonly search or retrieve off of customer name. So I may want to identify a secondary key at that point. Then I merge it into my overall database design. So I have to look at the rep table that I already had from my first user view, and then include with it the information that I've determined I needed in my table design for my second user view, and I merge them together. So here's my rep table represented by this rectangle. The field or fields above the line are my primary key. The field or fields below the line are additional attributes. Over here, customer number is my primary key, additional attributes. The dashed line represents the relationship, the dot represents the many. So now I go and I meet with a third group of users. And these users tell me that for a part, they need to store the part's number, description, how many units they have on hand, the part's class, the number of the warehouse that the part is located in, and the price. So I go back and I design this, and I determine that one table is needed, table part. I'm going to have the primary key of that table be part number, and I'm going to include a variety of additional fields in order to accommodate all the things that they want to be able to retrieve on. I would make sure that I'm normalized with only one table and a primary key. I would identify any other keys. Maybe I have a secondary key for the description. And I would merge that into my overall table design. So here's the table design I had before. Basically now I've just created one more table. And then I go and I meet with yet another group of users, and they tell me that for every order they need to store the order number, the order date, the number, name, and address of the customer who placed the order, the number of the sales rep who represents that customer. Additionally, for every item that they order, they need within that order, they need to know the part number and the description of that item, how many were ordered, and what price they were sold at. So after interviewing these users, I now have these requirements. So I'm going to go back and try to figure out my table design, and I determined that 4 tables are required. So in identifying that collection of tables, I determined that I need a table for orders, I need a table for customers, I need a table for parts, and I need a table for my order line specifics. I figure out what the primary key field or fields is going to be the primary key of each table. For my orders table, the order number, customer table, the customer number, part table, the part number, and for that order line table, I need the combination of two fields, order number and part name number, in order to uniquely identify each field in that table. I make a list of all the other fields they want that are necessary for the task at hand, and I plop them into the appropriate tables. So I've now determined my collection of tables, and I want to make sure that the tables are normalized. Then as step 3, I'm going to go ahead and identify the keys. So in identifying the keys, I determined that I need to add the customer number field up here to the table orders, the rep number field to the table customers. I figure out that I've got a foreign key here, functionally dependent on customer, foreign key here, functionally dependent on rep. I've got a couple foreign keys here with some functional dependencies on table orders and table part. And I also at this point would identify any secondary keys. What are they commonly going to want to retrieve off of? I would probably create a secondary key for order date, customer name, and description. If nothing else, I would probably go for those 3. And then I merge that into my overall table design. This is a little sloppy, but because my lines, I probably should have taken the time I did in the next one to draw them down and over rather than use diagonal, but it works. And I'd be fine with it if you turned it in this way. So I've got the representative table, customer table. I had those before. Now down here I have the orders table and the part table. Notice that my order line table is represented by a rectangle with rounded corners. This particular shape identifies that that table can be identified only through relationships to other entities. And notice now that I have solid lines down here rather than dashed lines. Again, they indicate an identifying relationship. So I have a many-to-many relationship. One order could have many parts. One part could be on many orders. So I break that down into 2 one-to-many relationships. And I can tell that because A, I have a rectangle with rounded corners. B, I have solid lines rather than dashed lines. So I have a couple visual clues as I look at my ER diagram. The second example in the chapter is on page 196, and it has actually 6 user view requirements. So in this case, I'm working with the Henry Books database, and I go and talk to a group of users, and they tell me that, well, they need to keep track of publishers, and for every publisher, they want to know the publisher's code, publisher name, and the city where the publisher is located. So when I come back to design that, I look to see what collection of tables I need, and I determine that only one table is required. I determine that that table should be named rep. I determine that the primary key of that table is rep number. I determine the other fields and any dependencies that there are. I'm then going to make sure the table is normalized, identify any keys, any additional keys, and merge it into my overall table design. In this case, I've identified a secondary key on publisher name. I guess I had the wrong table typed in there, so I've switched it now. So it's table publisher. Publisher code is my primary key, publisher name, and city. I identify that in addition to the primary key, I have a secondary key of the publisher name that's going to be commonly used for querying, retrieval, sorting, etc. So I want to define it as a secondary key. Of course, the next step would be to merge it into the cumulative design, but being the first table, it is the cumulative database design. So then I go and talk to another group of users, and they tell me that for each branch, they need to know the number, name, and location of the branch. So after speaking to them, I determine, again, by looking at what collection of tables is needed, that I need to have only one table branch. Determine that the primary key of that table is branch number. I determine what additional fields are required in order to meet the user needs. I just decide that I want to have a secondary key of branch name. and then I merge this into, so through this I've found my collection of tables, step 1, step 2, I've normalized, step 3, I've identified my keys, and step 4, I merge it into the overall cumulative design. At this moment, I have two tables and they're freestanding tables. There is no relationship between these two tables. Then I go and meet with a third group of users. They tell me when I leave there, I've determined that for each book, I need to know the code, the title, the publisher code, the publisher name, and whether or not that's in paperback. I come back and try to determine the collection of tables needed to meet this user view, and I determine that we need two tables. We need a table for publisher and another table for book. After I've determined what the tables are, I'm going to determine what the primary keys are for each of those tables and what other fields are required in those tables in order to meet the user needs. I may then determine that there is some functional dependency, so I'm going to need that publisher name in the book table in order to create the relationship. I have a foreign key of publisher name functionally dependent on publisher, on the table publisher. And then I merge it into my cumulative design. So now I have a relationship here between the publisher and this new book table. Remember, the relationship is represented by dashed lines. The circle on the end represents which end of that dash is the many. Then I go and meet with a fourth group of users, and they tell me that for every book they need to know the code and the type. They also need to know the authors in the order they appear on the book's cover, which is not always alphabetical order. After talking to the users and figuring out their needs, I determined that my collection of tables I need is 3 tables, one for the author, one for the book, and one for which author wrote which book. I identify the key fields within each of these tables, and I identify any other fields that are required to be included in those tables. I then identify any keys. In this case, I have 2 foreign keys on the wrote table. The book code shows functional dependence onto the table book and the author number to the table author. I then merge it into my overall cumulative design. So before I had these 3, looks like I've had to expand my book code table because I only had what I think that the book code and the type before. Now I've added a few more fields in here. I've had to add the author and the book table. I've got this table, you'll notice, is represented by a rectangle with rounded corners simply because it is accommodating the relationship between these two entities, and it's represented by solid lines rather than dashed lines. FK is foreign key, SK is secondary key. I go and meet with a 5th group of users. They determine that for every branch they need to know the branch's number and name. Additionally, for every book in that branch they need the code, title of the book, the condition or quality of the book, and the price. A branch, I find out, may have multiple copies of the same book and not always in the same condition. So they might have one book in excellent condition, another one in good condition. Those books wouldn't necessarily be at the same price. Each book copy is assigned a number to distinguish one copy from another, but it's a unique number only within that branch, not a unique number to the overall inventory of the company. After having met with the users and determining the task at hand, I come back and I sit down to decide on my collection of tables, and I determine that 3 tables are required: a branch, a book, and a copy table. I identify the primary keys for each of the 3 tables and any other fields that have to go into these tables. I then come back and determine, make sure they're normalized and identify the keys. So I have a foreign key, 2 foreign keys on the copy table, branch number to branch and book code to book, table book. And I merge it into my overall cumulative design. So what I have done now is I have another table down here represented by rounded corners. It has a 3-field primary key. Notice the line separating the key, primary key from the non-key fields. Solid lines mean and the routed rectangles that the only purpose of this table is to accommodate the many-to-many relationship between book and branch by breaking it down into two one-to-many relationships. Remember, the little dots or circles at the end of the line represent the many. So I've now linked that branch table into my design, and so based on these 5 user requirements, that's the overall design. There's a 6th user requirement in the example, but having talked to that group of users, I determined that every field they need is already in my overall design. And that's going to happen as I move from group to group. I'm going and discuss their needs. I'm going to find times where my database design has already accommodated the needs of that group of users. So at this point, I determined that my information level design is done, and now I'm ready to actually work on my physical level design, which the author begins to talk about back on page 201. Now, this is my process of actually implementing the design that I have into the selected database management system, be it Access or Oracle or a variety of other DBMSs. You really get into things that are very specific to each product. I'd have to know Oracle or Access or whatever I'm using in order to get into those specifics. But some things that are general enough, that are important enough when it gets to the physical level design to note, are that I need to ensure that my data restrictions are good. Some databases, management systems make this easier than others, but as the designer, it is my responsibility to make sure that my data restrictions are correct. For example, that employee number is the primary key and must be unique. Once I identify it as primary key in any database management system, that's going to make it unique. But remember, Social Security number was an alternate key? Well, that has to be unique too. And so I have to make sure that I code that in. I have to accommodate those sorts of things. Remember how we identified different secondary keys in the database design and the information level? Well, now that I hit the physical level, I need to make sure that indexes are built. Again, that's process to do that is different in different database management systems. I need to continually be going back to survey my users and talk to them. It's important that I review the paper forms or processes. Maybe it's a phone call that the order questions are asked, that the information is gathered, so that I make it as easy for them to input as necessary. When I get to actually designing the front end, again, I need to be working with them on designing those forms. So I'm going to be surveying, and I'm going to be asking and re-asking the end users all along the way. I, as the designer, need to make sure when I'm actually ready to do the physical level design that I have proper data validation restrictions, that I have the proper data types, that I know whether it's numeric or alphanumeric or alpha, that I know the field sizes. Do I know that that warehouse number is 2 alpha characters and I've restricted it to 2, no more than 2, no less than 2? Or maybe it's 2 characters, but there's only 5 choices, so I need to have a lookup value, or a way that I've restricted them to just those 5. Whether or not it came in paperback is a yes or a no. Have I restricted them to only those 2 answers, etc.? These are all the types of things that need to be thought of when I'm working with that physical design. And your author spends a lot of time in the chapter going over how to review the end users' documents, where they're getting their information from, listing these things out, etc. But it's really slightly different depending upon what DBMS you're using for that physical level design. There is some important information, though, on page 213, where the author spent some time talking about nulls. And remember that a null is a special value that represents the absence of a value. And it means that the value is either unknown or that value is not applicable in this particular situation. Kind of related to that are entity subtypes, also on pages 213, 214. An entity subtype is a subset of data stripped off into another table. Usually, the purpose of it is to avoid having a field that's going to have, half or a third or more of the records are going to have a null in that field. The example they use in the book is dorm number. Not all students live in dorms. So if I had a table for students and I included their dorm room number, I'm going to have a number of students where that's just null. It's not applicable. So one recommendation that you'll often see when you're designing that collection of tables is going to be to go ahead and strip that off into another table so that I create a table that's called a dorm table that tells me just the student number and the dorm number. A foreign key so that student number is functionally dependent on student and dorm number is functionally dependent on dorm, but my primary key is only the student number because a student couldn't be renting more than one dorm room. I wouldn't be allowing that. So the student number, student 6 is in dorm room 8. It is displayed a little differently in the ER diagram, which the author shows you there on page 214. The category symbol to let you know that the purpose of that table, that it is a one-to-one relationship, that it's just to identify that it is an entity subtype. Again, it's avoiding nulls. Some other great examples: fax number. Maybe I have a number of customers and I want to include a field for their fax phone number. Maybe they're home customers, residential customers. Well, some people do have fax machines at home, but most people don't. So I'm going to end up with 50% of my records null. So I may go ahead and pull that off into another table. Whenever I see that a lot of nulls and there's a lot of personal information, I'll pull off into other tables. Not everybody has an alarm code, for example, to get into their house, or so I may pull that off into another table. Maybe I was a cleaning company and I need to have a field for alarm code, or sometimes you'll see people include like um, every single possible type of telephone number, like what's their business phone number, their cell number, their fax number, their home phone, their assistant's phone number. Not everybody has these, so that's a great time to strip it off into another table with an entity subtype. Then they spend a number of pages here, starting on 217, to show you the actual ER model. This is the most commonly accepted entity relationship diagram. It represents data in a database. It is a little more cumbersome to create. I usually, while I can read an ER diagram, and I certainly can do it in this fashion, I'm usually designing it in something, or visually diagramming it in something much closer to what the author used in this chapter up to this point. The official ER model was developed in 1976 at MIT. In it, entities or tables are represented by rectangles and relationships are represented by diamonds. The attributes or the fields are represented by ovals. So if you flip open your textbook to page 219, you're going to see there how there's a rep represents a customer. Notice the 1 on the left-hand side of the line, the N on the right-hand side of the relationship. The diamond is the relationship itself. The rectangle rep and the rectangle customer are representing the two tables, and all the fields are out in various ovals, or we often refer to them as bubbles. There are going to be some that are composite entities. There's an picture of that in figure 639, top of page 220. There's the orders and the parts with that order line table. Now remember what the author used previously, they did a rectangle with rounded corners. Now you're doing the rectangle with the diamond inside to let us know that it is a composite entity. Another one you might see at times are weak entities. These are double rectangles. Page 221 has an example. See, the orders table is a weak entity, so it's represented by the double rectangle. A weak entity corresponds to the term dependent entity. already showed you how the one and the many come into play. If it's a many to many, they'll usually use an M and an N. I'm sorry, on the one to many, sometimes they'll use an N and an M. Sometimes they'll use a one. So you'll see some differences there. Crow's feet can sometimes be used. Figure 614, page 221 has an example of using crow's feet to represent the many. So I highly recommend that you do review pages 217 for 222 for your specific visual representations. You will be doing some visual diagramming for the chapter, for the homework examples in this chapter. So you may want to do the traditional ER model starting on pages 217, or you may want to do it in the IDE FIX style that the author uses, really beginning to that diagrams through the bulk of the chapter, pages 188 all the way up to 216. Either one of those methods. I think you'll find the one used within the chapter is probably going to be the easier one. And that concludes your lecture for chapter 6.